Hi, assalamualaikum everyone. Today we're going to introduce you guys about volumetric analysis in environmental monitoring, which is acid rain. First and foremost, I would like to introduce you guys our group members. So first we have Iman Hakim, and then we have Irfan, and it's me, Muhammad Aiman Hakim. We have Muhammad Hazi Aiman, and also lastly is Muhammad Ikan Fitri. So right now, I'm going to introduce you guys our introduction about volumetric analysis and also acid rain. First, we're going to take a look about our problem issues. So our problem is about acid rain, which can cause a lot of damage in this world. For example, we can see direct air pollutions, the damage of the plants, and also death of the submarine life. This is quite dangerous in our world because we depend on this thing, and it's also going to be more dangerous for us as a human. So now let's get a look what acid rain is. So acid rain is actually caused from air pollution, which is from human activities and natural sources. So this is when some sulfur dioxide and nitrogen oxides are released into the atmosphere. This is mainly is from burning fossil fuel and volcanic eruptions. So after that, they mix with water vapor, oxygen, and other chemicals in the air. This reaction produces sulfuric acid and nitric acid, which is a harmful acid, and this is why normal rain has become an acid rain. So now let's get to look how we can determine the acidity of the acid rain. So we're using volumetric analysis. So volumetric analysis is a chemical method used to determine the concentration of an unknown solution by measuring the volumes. It involves a process called titrations, where one solution is gradually added to another until a reaction is complete. This is by knowing how much of a standard solution is used, we can calculate the concentration of the unknown one. This method is especially useful in environmental measuring. For example, like how we're going to solve our problem today is acid rain. So it's helped chemists figure out how much of a substance is present in a sample, making available tools in lab, industry, and pollution studies.
Hi, my name is Iman. So now I'm going to explain to you guys about theory for titration. The basic principle of titration is neutralization reactions. Titration is an analytical technique used to determine the unknown concentration of a solution by reacting it with a solution of known concentration. The principle behind titration relies on neutralization reactions, where an acid reacts with a base to form a water and salt. The reaction typically continues until the acid and base have completely reacted, where this point is called the equivalence point. To determine this, an indicator is added to the reaction mixture. For example, phenolphthalein, which changes color when the reaction is complete. The most common type of titration used is the acid-base titration, where an acid is titrated against a base to determine the concentration of one of them. The common pairings for titration is strong acid with strong base. For example, hydrochloric acid reacted with sodium hydroxide. Second common pairings is strong acid with weak base. Third, weak acid with strong base. Lastly, weak acid with weak base, but it's less used due to indistinct endpoints. Okay, so basically, why strong acid and strong base commonly used for titration? It is because clear and sharp equivalence point, predictable pH change around the equivalence point, and suitable for precise and accurate measurement.
Hi, my name is Muhammad Ikan Fitri bin Muhammad Faizal, and we will discuss on how to better understand the relationship between acid rain and volumetric analysis. We will run through an experiment to determine the concentration of acidic components in an acid rain sample using acid-base titration. Now, we will explore the methodology of this experiment. Here are the list of apparatus and chemicals used in this experiment. We have rainwater sample, standard sodium hydroxide solution 0.01 mol per liter. We have burette, pipette filler, conical flask, clamp stand, phenolphthalein or methyl orange indicator, burette clamp, and burette stand. Next, we will go through the procedure of this experiment. First, the burette was rinsed with standard sodium hydroxide solution of 0.01 mol per liter molarity, and then the standard sodium hydroxide solution will fill into the 50 ml burette and air bubble is removed. The initial volume is recorded. Next, 20 ml of acid rain were pipetted into 250 ml conical flask. A few drops of phenolphthalein indicator is added into the rain acid sample. The rainwater is then titrated slowly with sodium hydroxide from the burette while the glass is then dissolved until the mixture color changes. The endpoint is then recorded. Step 3 to 6 is then repeated for 2 more times to get an average reading. And finally, the pH of the acid is determined.
Hi everyone, today I want to show or presenting you about the results and data analysis for this experiment, which is there are 3: titration result, equation, and determination of acid pH. Next, For this slide, I will show the result of our titration experiment. In this titration, we use sodium hydroxide now as the titrant. Table shows 3 trials to ensure the accuracy and consistency of our results. For trial 1, the initial burette reading was 0.00 ml and the final burette reading was 15.30 ml. This means the volume of now used was 15.30 ml. In trial 2, again starting 0.00 ml, the final reading was 15.10 ml. So the volume of now used was 15.10 ml. And lastly, for trial 3, the initial reading was 0.00 ml and the final reading was 15.20 ml, giving us a volume use of 15.20 ml. These results are quite consistent, showing only slight variations, which indicates good precision in our titration technique. From this data, we can conclude and calculate the concentration of the acid in our sample using the average volume of now used. Next, this slide was the balance equation. This is the balanced chemical equation for our titration reaction. In this titration, hydrogen ions from the acid in the rainwater reacts with hydroxide ions from the sodium hydroxide solution to form water, which is H2O. We assume that the rainwater contains monoprotic acids, meaning each acid molecule donates 1 hydrogen ion, or that the total acidity can be treated as if it comes from a single type of acid. This simple 1:1 ratio between H plus and OH minus make it straightforward to calculate the concentration of acid in the rain sample. Okay, to calculate the concentration of acid in acid rain sample, we use this formula. MA VA over MVB equals to A over B, where MA is the molarity of the acid, VA is the volume of acid, MB is the molarity of the base, VB is the volume of base used. A is the number of H plus ions provided by acid, and B is the number of OH minus ions provided by the base. Okay, since we are dealing with monoprotic acid and now, both and B are 1. Using our values, MB equals to 0.0100 mol per liter and VB is 12.5 ml or the average volume. VA is the 50.0 ml. When we substitute to the equation, we can conclude that the acid rain sample is 0.0025 mol per liter.
Hi, Assalamualaikum. My name is Muhammad Irfan and I'm going to talk about conclusion of volumetric analysis in environmental monitoring, which is acid rain. In conclusion, volumetric or titrometric analysis plays a vital role in monitoring the acidity levels of rainwater, especially in area affected by acid rain caused by environmental pollutants such as sulfur dioxide and nitrogen oxides. Other than that, this method uses a simple acid-base titration technique, which allows accurate quantification of acid concentration and helping scientists assess the severity of acid rain in affected area. Next, it is widely used because of its simplicity, low cost, and relatively high accuracy, making it an ideal tool for frequent environmental assessments. Through this analysis, scientists and environmental agencies can gather reliable data about the severity of acid rain in specific regions. More importantly, the information obtained from this analysis helps policymakers and environmental authorities to develop strategies to control air pollution, such as regulating emissions from vehicles and industrial sources. By understanding the level of acidity in rainwater, we can also take action to protect natural ecosystems, prevent damage to building and monument, and safeguard public health. Overall, the use of titrometric analysis in studying acid rainwater shows how basic analytical chemistry technique can be effectively applied to solve real-world environmental challenges.
Okay guys, this is our references. That's all from us. Thank you.